तेजस्विनावधीतमस्तु मा विद्विषावहै। ॐ शान्ति शान्ति शान्तिः।
Last few classes we were discussing about various processes in water treatment to remove the solids present in the water, and we have seen plain sedimentation, coagulation, flocculation, and even softening to remove hardness, and we discussed in detail about filtration. Today we will discuss about disinfection, because even if we remove the solids and the physical and chemical characteristics of water is very good, the water is not fit for drinking unless the bacteriological quality is safe, or bacteriologically the water is safe, because we have already discussed that bacteriological quality is the most important water quality parameter. The reason is, if a single pathogen is present in the water and if it enters in our body, there is a chance of getting diseases. So it is very, very important that the water, whatever we are supplying or whatever we are drinking, is bacteriologically safe. So for that purpose only we are going for disinfection. So we will see what is this disinfection. Disinfection is the process in which the pathogen organisms are destroyed or inactivated. So disinfection is only destroying the pathogenic organism, but it is different from sterilization. Sterilization means killing all type of organisms, whether it is pathogen or non-harmful microorganism, we are killing everything in sterilization. So there is a distinct difference between disinfection and sterilization. But though we tell that disinfection, all the pathogens are killed, but most of the time it is not the thing, because we don't have any measures to see whether all the viruses are getting removed from the water and all. So now we will discuss what are the different methods of this disinfection. We can remove the microorganism by various processes, because we have seen various unit operations and processes in water treatment, the physico-chemical treatments. In each and every unit there will be bacteriological or microbial removal taking place, but we won't be able to achieve 100% removal in any of these processes. That is why after a series of treatment processes we have to go for disinfection separately. Then another method of killing the microorganism is direct application of thermal energy. This process was being used in age-old days. And another one is ultraviolet, gamma and Xray, X-rays and microwave radiations. Because you know that if you open the water to the sunlight and keep it for long time, it will be getting disinfected. The reason is the ultraviolet rays, whatever is coming from the sun, it is responsible for the killing of the microorganism. And the another method is ultrasonic disruption, because this ultrasonic rays will be going and it will be disrupting the cells of the microorganism. And the other method is addition of chemicals. This is the one most commonly practiced in water treatment plants. Then there are other things, because if you keep the water for long time in some storage tanks, what will happen? The microorganisms will not be having the conducive environment for their growth. So natural death will be taking place. This we will discuss in detail when we come to wastewater treatment. There we have some polishing units, especially to kill the E. coli and these pathogenic organisms. What we do there is, we allow the water to stand for long time under sunlight, for example in oxidation ponds. So what will happen? Oxidation pond is getting exposed to sunlight, and sunlight, you know, it is having UV radiation. Because of that one, the microorganisms are getting killed. And I have already told that there is a distinct difference between disinfection and sterilization. Sterilization is the process in which complete destruction or inactivation of microorganisms are taking place, and disinfection, only pathogenic organisms are getting killed. So now we will see there are various methods for disinfection or killing the microorganism from the water. So what is the property, okay, that make a good disinfectant? These are the properties. The disinfectant should be able to kill all pathogenic organisms, okay, and it should be effective in a wide range of pH and mineral compositions, because we will be coming across various types of water with various degree of pollution and various pH conditions and mineralogical conditions. So if the disinfectant or the chemical or the method whatever we are selecting, if it is applicable only for a narrow range of values of pH and mineral compositions, then it is not a good disinfectant, because if we want to have 100% efficiency, what we have to do, we have to bring the entire water to that specified composition. So a good disinfectant is the one which is able to remove or kill the microorganism for a wide range of conditions. And the next point is, there should not be any toxic byproduct produced during the disinfection process, because mostly chemical reagents are there. When it acts with the water or when it reacts with the microorganism and inactivate that one, during that time it should not form any byproduct which is toxic. And the fourth point is, there should be some residual effect of disinfectant after the disinfection process is over. This is required because after the disinfection or after the complete treatment, what we do, we usually put the water in the distribution system. So there are chances of bacterial entrance or pathogenic entrance into the distribution system. So we have to keep the water free of microorganisms or pathogens till it reach the receiver or the consumer. So for that there should be some residual disinfectant property left over. So these are the four properties or four important properties to select a good disinfectant. Now we will see what is the mechanism of disinfection. Though the mechanism of disinfection is not yet completely clear, one thing is very sure, the disinfectant whatever we are adding, either it is chemical, thermal or any other radiation, it will be acting on cell protein to inactivate the critical enzyme system essential for microbial life. So once it is inactivating the microbial system, what will happen? The microorganisms are no more able to survive or support the life. So naturally they will be dying. So that is the mechanism. So, or in detail we can tell like this: it damages the cell wall and it alter the cell permeability. So what will happen when the cell permeability is altered? The cell material whatever is present inside the cell wall will be coming out of the cell. Okay, so that will be destructing the cell viability. And the third one is changing the colloidal nature of the protoplasm, because these chemicals will be acting with the protoplasm material and it will be changing the colloidal nature of that one, or it will be inactivating the cell material. And the last and most important one is, the disinfectant will be inactivating the critical enzymes. Critical enzymes are those enzymes which are responsible for all life supporting reactions or all life supporting functions of the cell. So now we will see what are the steps involved. So if these are the mechanisms, either they will be altering the cell permeability or attacking the cell or reacting with the critical enzymes. So how it is happening? What are the steps involved? So we know that one chemical is present and the microorganisms are there in the same water. So that first the chemical has to come and reach the cell wall. Okay. So and it has to penetrate through the cell. So unless it enters in the microbial cell, it cannot reactivate, it cannot deactivate the cell component. So first step is the chemical coming close to the cell and entering through the cell wall. That is the first step. And second step is, once the chemical is entered in the cell, it has to react with the cell components and inactivate that one. So these are the two major steps of disinfection. So from this one it is very clear that the disinfectant or the material whatever we are using, if it is not having any charge, okay, then it will be having high chance of getting penetrated to the cell, because we know that whenever the bacterial cells are present in aqueous medium, it will be having a negative charge. So, if your disinfectant is a negatively charged ion, what will happen? There will be a repulsive force between the cell and the disinfectant. So, that ion will not be able to penetrate through the cell wall. Unless it is penetrated through the cell wall, we will not be, or the chemical will not be able to deactivate the cell. So, that is the reason either cations or the ions without any charge are the best disinfectants. So, mostly neutral ions are more active compared to anions. That is why chlorine, ozone, chlorine dioxide, etc. are being used as good disinfectants. So, this ozone and chlorine dioxide, what they do is, when they enter in the cell, they are having very high oxidizing capacity. So, they oxidize the cell matter beyond inactivating the critical enzymes. Now, we will see what are the most commonly used chemical disinfectants. We can use halogens. The most commonly used halogen is chlorine, because in India we practice chlorination as the most commonly used disinfection method, and bromine and iodine are being used in some places, and ozone is a very good disinfectant, but the problem is it is expensive and it also destroys color and odor effectively. But another disadvantage of this ozone is it will not be having any residual effect. So, another oxidizing agents like KMnO4 and H2O2 are also being used as chemical disinfectants. Then metal ions, for example silver ions, it is acting as a bactericidal, and copper can be act as algicidal and fungicidal, because you know very well copper sulfate is being used in swimming pools to control the algal growth. And you have heard about, in India nowadays in most of the households use water purifiers. In most of the water purifiers, the adsorbent or the activated carbon which is used for removing the turbidity and color and odor, it will be coated with these silver ions to remove the pathogens. So, silver is being commonly used in such domestic water treatment units. Then another method is using alkali and acids, because if you know that the microorganisms are able to survive under a particular pH value. If you reduce the pH less than 3, or if you increase the pH above 11, what will happen? The environment will not be conducive for the growth of microorganism. So, this one we can use for the disinfection purpose. That means, if you can decrease the pH less than 3 by adding some strong acids, or if you can increase the pH by adding some strong alkali, the medium will be, or the water will be free of microorganisms. Now, we will see what all are the factors influencing chemical disinfection, because we have seen that what all are the mechanism of disinfection and what all are the various chemicals we can use for disinfection. So, it is very important to know what are the factors that affect the disinfection, because unless we know that one, okay, we will not be able to achieve 100% disinfection. So, the first and most important one is nature of the organisms and concentration and distribution of the microorganism in the system. The nature of microorganism means if it is in colloidal form, or if it is present as discrete particles in the water, then it is very easy to destruct them. The reason is the chemical will be going and attacking them directly. But if the microorganisms are in the form of flocks, what will happen? The chemical will be getting exposed, the microorganism which are present in the outer surface of the flock will be getting exposed to the chemical, but whatever is there sitting inside, okay, they will not be getting exposed to the chemical that much. So, what will happen? Unless the chemical dose is very high, the microorganism whatever is there in the center of the flock will not be getting destroyed. That is one reason. And another one is, you know, yeast and all, they will be forming cysts. So, these cysts are highly resistive to these chemicals. So, if the microorganism are of cyst forming nature, then naturally it will not be getting destroyed or destructed using any of these chemicals. So, and if you have very high concentration of the microorganism, then also it is very difficult to achieve 100% disinfection unless we add very high dose of disinfectant. So, the nature and concentration, nature, concentration and distribution of microorganisms are very, very important. And second one is nature, distribution and concentration of the disinfecting substance. So, how well we are distributing the chemical and what is the concentration we are providing and what is the nature of the disinfectant, all those things are very, very important. Because if we are giving the chemical dose lower than whatever is required for killing the microorganism, then naturally the microorganisms are not going to get destroyed. So, similarly, if the chemical or the agent whatever we are adding for disinfectant, if it is not very stable, it will get dissociated immediately, then also it will not be an effective disinfectant. And third one is the temperature, because we know any reaction, any chemical reaction or biochemical reaction, temperature is very, very important, because as the temperature increases, the activation energy of the reaction will be increasing if it is. So, definitely high temperature will be preferable for high rate of disinfection. And the next one is the rate and condition of water to be disinfected, because if the water is having lot of turbidity, what will happen? This turbid particle will be acting as a protection for the microorganisms. What will happen? The microorganism will be going and get attached to this turbid particles, and when the chemical is applied, okay, this microorganism will not be getting exposed to the chemical completely. So, destruction of the microorganism become very, very difficult. So, this is one of the reasons why there is a standard for or there is a limit for turbidity present in drinking water. We know that it is 1 NTU. If the turbidity is small, disinfection will not be effective. And another one is if the water is highly contaminated with organic matter or some inorganic compounds like ferrous, manganese, etc. What will happen? The chemical reagents whatever we are adding, and we have seen that most of the chemical reagents whatever we use for disinfection all are having high oxidizing capacity. So, what will happen when we add these chemicals to the water? The chemical will be used by the organic matter or the inorganic compounds present in the water. So, the chemical will be completely utilized for the oxidation of these compounds. So, the microorganism will not be getting exposed to high concentration of these chemicals. So, naturally the disinfection will not be proper. So, if you want to have a high efficiency of disinfection, the water whatever we are subjecting for disinfection should be clear of turbidity, organic matter and other pollutants. And the last thing is the time of contact, because if the microorganisms are getting exposed to a toxic compound for longer time, definitely the rate of kill will be more. So, time of contact is also very, very important. So, now we will see how can we find out the rate of disinfection. So, the most commonly used law or the most famous law of disinfection is this Chick's law of disinfection. So, how can we relate the contact time and the rate of disinfection? So, this is the relationship Chick has given, minus dN by dt is equal to k into n, or rate of kill is proportional to the number of microorganisms present. So, here dN by dt is nothing but rate of destruction and k is a rate constant and it is the characteristics of the organism. Okay. So, this k is not a constant, it will be varying with respect to the reagents or the disinfectant as well as the microorganism. So, if you integrate the expression, then we will get ln n by n naught is equal to minus k into t, where n naught is the initial number of microorganisms present in the system and n is the number of microbes present after a time t, or we can find out n whatever is the remaining number of microorganisms, that is equal to n naught into e raised to minus k into t, or Chick's law of disinfection is telling rate of disinfection is proportional to number of microorganisms present. Okay. It is not giving any relationship between the concentration of the disinfectant or the nature of the organism. Everything is taken care by this k, but this statement is true only if all the microorganisms present in the system are having uniform susceptibility to susceptibility to the chemical. That means if the microorganisms all are having same resistance or same toxicity for the chemical. For example, if we take the water, we know that pathogens are present, and Escherichia coli, which we use as indicator organism, that also will be present in the water. But if you consider these two types of microorganism or bacteria, the pathogens are having less resistance to chlorine compared to E. coli. So naturally, if you apply a particular amount of chlorine to that water, and if you see the number of microorganisms separately, naturally the pathogenic organisms number will be getting reduced at a faster rate compared to E. coli. So Chick's law is valid only if uniform susceptibility of all species present to the particular disinfectant, and the second important point is constant concentration of disinfectant. But we know that when we add the disinfectant to the water, with respect to time, the concentration of the disinfectant or concentration of the chemical will be getting reduced. So at a reduced concentration, the effect on the microorganism will be less. So Chick's law is not considering that effect also. So that law is considering concentration of the disinfectant is remaining same, or concentration of the disinfectant is not having any effect on the disinfection or rate of kill, but that is not true. And the third one is absence of any interfering compounds. For example, if organic matter is present or iron or manganese is present in the water, certain amount of the disinfectant will be used for the destruction of those material, and the remaining only will be available for disinfection. So that is also not being considered in Chick's law of disinfection. And another one is well defined conditions. Example, pH, temperature and ionic strength. These parameters are also not considered in Chick's law, because if pH is different, what will happen? The effectiveness of the disinfectant will be different. Similarly, temperature, high temperature the activity will be more compared to low temperature, and ionic strength also is having a comparable effect on disinfection. And now we can see that, okay, as we have seen till now, the rate is a constant, but rate can increase or rate can decrease. When the rate can increase, for example, initially the concentration of the disinfectant is less, okay, with respect to time, what is happening? The microorganisms are there in the same water and the disinfectant is there in the water. So what will happen with respect to time? The chemical or the disinfectant will be getting accumulated in the cell wall. So it will be getting accumulated, and at a certain stage what will happen? The concentration of that chemical will be exceeding the maximum permissible concentration which the body of the microorganism can withstand. So what will happen? Once that concentration is reached, the microbial destruction rate will be increasing. That's why rate can increase when accumulation of lethal dose takes place. Then when can the rate decrease? The rate can decrease when the cells increase the resistance to that particular chemical. So we all are aware that if you keep on giving certain medicine, the microorganism will not be responding to that medicine. Okay, some bacteria or some microorganism will be developing resistance for certain disinfectants or certain chemicals. So if the microorganism can develop the resistance in a short period of time, what will happen? Initially it will be getting killed at a faster rate, but with respect to time, as they have already developed the resistance for that chemical, so the rate of kill will be decreasing. So we can modify the Chick's equation like this: minus dN by dt is equal to k into n plus k2 into n into n naught minus n. So this is the velocity of acceleration. Okay, this will, so or we can write in another way: minus dN by dt is equal to k by 1 plus alpha t into n, or n is equal to n naught into 1 plus t raised to minus k by alpha. So here alpha is the retardation coefficient. That means if the cell already develops some resistance, what will happen to this rate k? So this alpha is a number which is more than 0. Then what will happen? This k value will be getting reduced. But if the cell is not developing any resistance, then what will happen? This value will be 0. So, you will be getting the same equation, minus dN by dt is equal to minus Kn. So, this term will be taking care of the retardation, okay, and this will be taking care of the velocity acceleration, because we know that whatever is the n, okay, depending upon that one, okay, it will be varying. So, this is the one which take care of the velocity acceleration, and this is the one which take care of the retardation coefficient. So, the rate of kill may not be or need not be a constant always. And we have seen that, okay, Chick's law is taking care of only the number of organisms present, but the concentration of disinfectant is also very, very important. So, that we can represent using this formula. C raised to n into T is a constant, okay. So, this n can have any value between 0 to 1 or above that one. If n is equal to 1, that means concentration and time are very, very important for disinfection. If n is having a low value less than 1, then concentration is less important compared to the contact time. If n is greater than 1, then concentration is more important than the contact time. So, this we will see when we discuss in detail about other chemicals whatever we are using as disinfectants and how their behavior is. Now, we will see how the temperature effect is coming into disinfection, because we know that as the temperature increases, the activation energy of the reaction also will increase. So, the rate of disinfection will be changing or increasing with increase in temperature. So, this equation show that one temperature ln n by n naught, this is the number of microorganisms present at any time t, and this is the number of microorganisms present when t is equal to 0. That means before the disinfection, that we can write like this, K1 into T1, K1 is the constant and T1 is the time. Okay, this is at time at a temperature T1 degree Kelvin, and same is written here for a temperature T2. So, the rate of this rate constant is changing and contact time is changing, but we know that in both the cases this term is same. So, we can equate K1 T1 equal to K2 T2 or ln K2 by K1, because K1 and K2 are the rate constants at different temperatures, that is equal to ln T1 by T2, that means the contact time. So, which is equal to E into T2 minus T1 by R into T2 T1. R is the universal gas constant. So, this is very, very important. So, rate of kill or the rate of disinfection varies with respect to temperature, and if you know the rate of disinfection at a particular temperature, we can find out what is the rate of disinfection at another temperature using this formula. So, this is the famous Van Hoff's equation. Now, we will discuss about the disinfection by chlorine, because chlorine is the most commonly used disinfectant in India. In developed countries, chlorine is banned because of various reasons. The major reason what they are telling is the chlorine can create carcinogenic compounds with the organic compounds present in the water. So, chlorinated organic compounds, most of the chlorinated organic compounds are carcinogens. So, if organic matter is present in the water, when we apply the disinfectant, what will happen? They will be forming chlorinated organic compounds. So, these compounds will be present throughout the water. So, what will happen? When we drink the water, these compounds will be getting accumulated in our body, and most of these compounds are synabiotic in nature. That means very, very difficult to destruct. So, what will happen? It will be getting accumulated in our body and it can cause cancer. That is the reason why chlorine is banned in developed countries, but in India it is being used now also, because we have seen that the risk involved because of the carcinogenic nature of the compounds created by chlorine is much negligible compared to the disinfectant characteristics of the chlorine. So, that is why we are using chlorine very commonly in India. So, first we will see what is the reaction taking place when chlorine combines with water. So, this is what is happening. Chlorine reacts with water to give HCl plus HCl, hypochlorous acid and hydrochloric acid, and HCl, what will happen? It can dissociate as HCl and H plus and OCl minus. So, this reaction is very important, because we have seen that when we talk about disinfection, neutral molecules are more effective compared to charged ones, especially if it is having a negative charge, because most of the microorganism will be having a negative charge. So, when HOCl is dissociated to OCl, OCl is having a negative charge, that will not be able to penetrate the cell wall as effective as HOCl. So, HOCl is very important as far as chlorine disinfection is considered. So, that is why the pH is very important, because what will happen at high pH, HOCl will be dissociating to H plus and OCl minus, and OCl concentration will be very high, whereas HOCl concentration will be less. But at low pH, what will happen? This one, HOCl will be predominant compared to OCl minus. So, the disinfection will be more effective. So, that is what I have written here. The distribution of HOCl and OCl are pH dependent, and the sum of HOCl and OCl, whatever is present in the water, that is known as free available chlorine. So, here again I have given the reaction Cl2 plus H2O gives HOCl plus HCl. Okay. So, we can find out what is the equilibrium constant for that reaction, HOCl into H into Cl minus by Cl2. So, this is the equilibrium constant for that reaction, and this is the reaction with HOCl. HOCl dissociate to form H plus and OCl minus, and Ka equilibrium is 2.5 into 10 raised to minus 8 at 20 degrees centigrade, and we know that it is a function of pH, because H plus ion is coming here. Or if you know the pH of the water, and if you know what is the total amount of HOCl present in the system, then we will be able to find out what is the percentage HOCl, because we know that HOCl is having 100 times more disinfecting power than OCl minus. So, this is also very important. So, our aim is to maximize whatever is the HOCl component present in the water compared to OCl minus. So, this graph shows how the HOCl and OCl distribution with respect to pH. We can see that at around pH 7, both HOCl and OCl will be almost equal, but if the pH is slightly lower, then what will happen? Almost all will be in the form of HOCl, but if the pH is higher than 9, then what will happen? Everything will be in the form of OCl minus. So, in water disinfection, if the pH is in alkaline side, the disinfection efficiency will be very less compared to acidic range. And this chlorine, it can react with ammonia present in the water also. So, these reactions are also very important. So, what will happen? This ammonium ion, whatever is present in the water, is combined with water to form ammonia and H plus. So, this is the reaction, and whatever ammonia is present, that will react with the chlorine to form chloramines. So, first ammonia, one hydrogen ion will be replaced by chlorine ion. So, we will be getting NH2Cl. This is known as monochloramine, and after that one, what will happen? This monochloramine will be reacting with another molecule of or another atom of chlorine to form NHCl2 or dichloramine. It is having 2 chlorine, and again it will be reacting with 3 chlorine to form trichloramine. So, if you further add chlorine, what will happen? This will be dissociating, and N2 gas and chlorine will be regenerated, and N2 gas will be escaping from the system. So, if you have ammonia present in your water, so we have to add more chlorine to remove the ammonia. So, if you add the chlorine to the water, and if you measure the residual chlorine and added chlorine, and if you plot it, we will be getting a typical curve like this. So, this is known as breakpoint curve or breakpoint curve. It is very important. See, initially what is happening is, up to here the residual chlorine is almost nil. So, this is used for the destruction of whatever other compounds. We have seen that if organic matter is present, it will be used for the destruction of organic matter. Then if microorganisms are there, that also will be getting destructed. So some amount of chlorine will be used for the destruction of the organic compounds present in the system. So there will not be any residual chlorine at all. So after some time what will happen, all those things are destructed, then ammonia is present in the system. So what will happen, monochloramine, dichloramine, trichloramine, all those things will be forming in a stepwise manner. So if you find out the residual chlorine will be a sum of HCl, OCl and monochloramine, dichloramine and trichloramine. You will be getting a curve something like this. And at this point B, what will happen, all the ammonia whatever is present in the water is already converted to trichloramine, that means NCl3. So if we add some more chlorine, at that time what will happen, this trichloramine will be dissociating and nitrogen gas will be going out and chlorine will be coming. So your combined residual chlorine will be coming down because NCl3 is getting destructed from the system. So this is the break point, that means all the chloramines and chloroorganic compounds are getting destructed from the system. And if we further add chlorine, what will happen, this is the free and combined residual chlorine, and whatever up to this point, okay, this is the origin, up to this point, that is the combined residual chlorine. So some more chloramines whatever is present in the system that we can get from here, and this portion up to from here to here, this gives you the free residual chlorine, and this is the breakpoint chlorine. So this breakpoint is very, very important. So if you want to find out the disinfectant concentration required, so what we have to do, we have to prepare this breakpoint and we have to add chlorine up to this breakpoint and add little more to maintain the residual chlorine whatever is prescribed by the standards. So this is the typical curve for water if it is having ammonia. So if you have only distilled water and if you add chlorine, how the curve will be? It will be a line at a 45-degree angle, because whatever you are adding, it will be available as chlorine residual. So it will be a 45-degree line. But if you have a solution which contains some glucose or something like that, okay, so what will happen? So initially some chlorine will be utilized for the destruction of the organic matter or the glucose solution, then again it will be rising at an angle of 45 degree. Okay, you will not be getting this type of a curve. This is typical of the presence of ammonia. So sometimes in water treatment system what people do is, this combined residual chlorine is much more stable compared to the free residual. So if you want to maintain the residual chlorine effect for longer time, so after all the treatment, little ammonia will be added to the system before chlorination. So what will happen? Some combined residual chlorine will be there. So that will be remaining in the system for longer time. So what is the mechanism of chlorine disinfection? So we have already discussed the mechanism. So we can see that one again. So cell penetration into the cell wall. So cell wall is negatively charged. So we can see that HCl can easily enter in the cell, whereas OCl will be having some resistance. That is why HCl is 100 times more active than OCl minus, and Cl to affect the sulfitryl enzyme which is required for the oxidation of glucose. So sulfitryl enzyme is the one which generates the energy. So the chlorine will go and act on that enzyme. So the energy generation system will be getting affected, and it also inhibit the respiratory enzymes and also inhibit the phosphate uptake, and permeability of the cell membrane is altered and leaching of the cell material will be happening. So chlorine is having all these properties. So in all these ways it will be destructing the cell. That means permeability changes, phosphate uptake is getting affected, respiratory enzymes are getting affected, sulfitryl enzymes are getting affected. So the cell will not be able to survive at all. And now we will see what are the different types of chlorination. Okay, we can classify the chlorination into basically 5 categories depending upon the point of application. First one is plain chlorination, other one is pre-chlorination, post-chlorination, breakpoint chlorination and dechlorination. So by the name itself it is clear what is plain chlorination. Plain chlorination is the one where no other treatment is there, only chlorination is given as a treatment to the system. So, this is practiced mostly in case of emergencies. So, the water treatment system is not working at all. So, what one has to do, we have to make sure that the water we are supplying is free from pathogens. So, because if the water is not safe chemically or physical appearance wise, it can be tolerated for short period of time. But if the water is not safe bacteriologically, cannot be tolerated even for a single hour, because what will happen if pathogens enter in our body, it can cause diseases. So, whatever be the condition, we have to make sure the bacteriological safety of the water. So, in emergency purpose, or if your water source is very clean or it is unpolluted, then we can only go for plain chlorination. We do not have to go for any other treatment. So, surface water with no other treatment, we go for plain chlorination. If in such cases, what will happen, if high organic content is there, high chlorine dose is required, and when we go for plain chlorination, we have to make sure that a combined available chlorine of 0.5 milligram per liter is available after the chlorination and after the contact time, and the turbidity should be less than 5 to 100 NDU, preferably 5 NDU, because if more turbidity is there, the disinfection will not be effective, and Fe and Mn should be less than 0.3 milligram per liter. So, if the concentration of Fe and Mn is higher, what will happen? This will be utilizing the chlorine, which is a strong oxidizing agent for the oxidation of Fe2 plus to Fe3 plus and manganese. So, whatever chlorine you are adding, mostly it is used for the oxidation of the other pollutants. Okay, and that is why we tell the plain chlorination can be applied only to relatively unpolluted sources. Now, next one is prechlorination. Prechlorination is nothing but the application of chlorine before any other treatment. Okay, it is having certain advantages. Okay, it improves coagulation, especially if you are collecting the water from some stagnant water bodies. What will happen? It will be having lot of algae present in that one. So, removal of algae by coagulation flocculation is very difficult, or we have to add excess alum dose to remove the algae. But if you add chlorinate the water and kill the algae, then it become very easy to remove. So, improve the coagulation. So, and the next one is if some organic matter is present and if you chlorinate it, chlorine can oxidize the organic matter. So, it reduces the taste and odor of water. So, by reducing algae and other organisms, keep the filter sand cleaner. Otherwise, these microorganisms will be growing on the filter sand and filtration will not be effective, especially the rapid sand filtration. And its effectiveness depends upon the residual chlorine concentration available. If you have sufficient residual chlorine, then all the treatment units will be protected from bacterial growth, and preferred residual concentration is in the range of 0.1 to 0.5 milligram per liter. So, if the residual concentration is low, then it will not be having the effect. So, it is always advisable to keep a residual chlorine concentration of 0.1 to 0.5 milligram per liter. Now, the other one is postchlorination. That means addition of chlorine after all other treatment. So, this is the most commonly practiced one. So, what we do after the filtration or after the end of all the treatment units, whatever the clean water coming, we are adding the chlorine and allow it to stand for 30 minutes, because usual contact time given in chlorination unit is 30 minutes. So, what will happen at that time? Whatever the microorganisms are present, okay, it will be getting killed. So, that is known as postchlorination. This is the most commonly practiced one. And in postchlorination, if you want to find out the dose, what we have to do? We have to find out the break point and add some dose which is slightly higher than the break point, so that the required residual chlorine is present. Now, we will see what is this dechlorination. Dechlorination is practiced when we need quick disinfection, when the water is highly contaminated. We know that the water is having lot of pathogens present in that. Okay. So, at that time what we have to do? We have to add heavy dose of disinfectant to that one, so that all the pathogens will be getting killed very fast. Then afterwards take the water for all the treatments, but after all the treatments, if you taste the water, it will be having lot of this disinfectant taste. So it will not be acceptable by the public. So this high residual, and it is not advisable to send it into the distribution system. So if high residual is present, then we have to go for dechlorination. That means high chlorination, we are going high dose of chlorine, and the residual chlorine dose is very high. So we have to remove the excess chlorine whatever is present. So we are going for dechlorination. Now we will see what are the methods we can practice for dechlorination. One is aeration. When you do aeration, whatever is the dissolved gases, it will be going out. So we can use this method for removing the excess chlorine. And another one is addition of sulfur dioxide, sodium bisulfite or sodium sulfide. So you know that all these things are reducing agents. So sulfur dioxide is a reducing agent, so it will be getting oxidized to sulfate. Similarly, sodium bisulfite and sodium sulfide. And you know chlorine is a very strong oxidizing agent, so chlorine will be getting reduced to chloride, and these compounds will be getting oxidized to the corresponding compounds. So this is the reactions. And another method is adsorption on activated carbon. So SO2 and chlorine react to give H2SO4 and hydrochloric acid. Similarly, sodium bisulfate and sodium thiosulfate, okay, all these things can be used as removing chlorine or dechlorinating agents. Now we will see what are the disadvantages of chlorine. This I have already mentioned in the initial slides. One is formation of chlorophenols. If the water is having phenols, what will happen? This chlorine will be forming, reacting with the phenols to form chlorophenols. It is having a very bad smell, fishy smell. So if phenol is present in the water, and if you go for disinfection using chlorine, you will be getting taste and odor. And another one is formation of carcinogenic compounds, which are chlorinated organics. So these are the major problems with chlorine. Now we will see what are the non-chemical methods for disinfection. One is thermal method. This is direct application of heat energy. Naturally, if you go for this, nearly complete sterilization takes place, and we know that the energy involved in this process is very high. So it is applicable only for small volumes of water, and thermal resistance varies from cell to cell. So even if you boil the water and keep it boiling for some time, certain cells will not be getting destructed. Now next method is UV radiation. Okay, UV can destruct the cells. UV may kill the cell, retard its growth, or change its heredity by gene mutation. So these are the action how the UV radiation is killing the cells, and it will be acting on the nucleic acid, and you know that nucleic acid, DNA and RNA are there. So what will happen? This DNA and RNA will be getting affected. So UV will be directly affecting DNA, RNA. So mutation of the gene can take place, and it can retard the growth. And when UV radiation is acting on water, it can produce H2O2. So H2O2 is a strong oxidizing agent. So this oxidizing property of this H2O2 is also one of the reasons of the destruction. And the major disadvantage of UV radiation is there is no residual effect, and it is costly compared to chlorination. And another one is gamma and Xray radiation. Any electromagnetic radiation can kill the cells, and it can penetrate and destroy the cells, but again, okay, it is very costly, so not usually practiced in water treatment plants. Now coming to ozone. Ozone is a very good disinfectant, but here we can see that ozone is having a peculiar nature. It will not be having any disinfection property up to a certain concentration, okay, and once it reaches that concentration, the disinfection or the efficiency increases drastically. See, so this is the surviving microorganism, this is the chemical dosage. So it is having a no or complete effect. That is the case of ozone. But chlorine, you can see that at low concentration itself, it is having some disinfection concentration, and it will not be having 100% like ozone. Okay. And advantages of ozone is it is a strong oxidizing agent and immediate bactericidal properties are there, and it can work on any pH, because we have seen that chlorine can work only that acidic range, but ozone can work under any pH condition, and mode of action of disinfection is similar to chlorine, and it attacks dehydrogenase and respiratory system, and when ozone reacts with water it produces hydroxyl radicals and HO2 radicals, and this plays a significant role in disinfection, and hence it is effective for cysts and even viruses, but again it does not have any residual property. So, how can we add chlorine? So, chlorine can be added to the system by addition of a weak solution prepared from bleaching powder, addition of weak solution by electrolyzing a solution of brine, or by addition of chlorine as gaseous form. So, different forms we can add chlorine, and when we use, most of the times in water treatment plants use chlorine gas. So, we have to be very careful when we handle chlorine, because it is very toxic. So, cylinders should be stored upright and ready access and easy removal is possible, and you know that chlorine is very dense compared to air. So, the chlorine storage rooms will have should have proper ventilation, and the ventilation should be placed in the lower side of the room. The reason is it is heavier compared to the air, so all the chlorine will be getting accumulated in the bottom. So, if you want to remove that one effectively, the ventilators should be placed in the bottom of the room. Then this is the commonly used chlorinator. You can see the chlorine, this is the meter which adjusts the flow rate and all those things. So, what will happen, some water is coming here and chlorine gas is coming. So, this is an absorption tower. So, what will happen here, the chlorine is getting mixed up with the water and we will be getting a weak solution of chlorine that will be going to the water. So, this is another chlorination panel. Another method here, an injection tray is there and vent hose is there, and this is the water coming. So, it will be coming here and mixing with the chlorine, and whatever is the mixed chlorine solution is coming out, and it will be going to the tank which is meant for the disinfection, and this is whatever the gas generated. Okay. So, we can vent through this hose. Now, we will see what are the most commonly used chlorine compounds in India. Bleaching powder. Bleaching powder is very commonly used, and in bleaching powder the available chlorine is only 20 to 30%. So, when we make the calculation of the dose, we have to be very careful, because available chlorine is only 20 to 30%. Another one is hypochlorites. Here available chlorine is 60 to 70%, and another one is chlorine dioxide. Chlorine dioxide is having one advantage, it is efficient for a pH range of 6 to 10. So, if you have highly alkaline water and if you want to disinfect that without bringing the pH to 7 or lower, then you can go for chlorine dioxide. And we know that we have to maintain a chlorine residual in the distribution system, because we have to take care of the microorganisms whatever can enter in the distribution system. So, according to the standard, we have to maintain 0.3 to 0.4 milligram per liter of residual chlorine in case of prechlorination, and 0.5 milligram per liter in water works, especially when the cyst of E. histolytica is present. That means cysts cannot be destructed by low concentration of chlorine, and 0.5 milligram per liter of free chlorine is present for 1 hour, it can inactivate viruses, and 0.4 to 0.5 milligram per liter for 6 hours can inactivate nematodes. So, now we will see what all the things we have discussed today. We know that disinfection is a very important treatment for water distribution, because water should be free from microorganism, or bacteriological safety is the most important water quality parameter, because the effect will be immediate compared to chemical parameters and physical parameters. And disinfection can be done by various methods like any of the physical chemical method, it can remove a certain amount of microorganism, but the removal is not 100%. Then by direct application of heat, then UV radiation, ozone, chemicals we can go for any halogens, chlorine, bromine, iodine, then potassium permanganate, H2O2, ozone, etc. And we have seen the mechanism of disinfection. What is happening? The chemical will be penetrating into the cell and deactivating the active enzymes which is responsible for the life supporting reactions. So, that is the mechanism of almost all the disinfectant. And we have seen that the most commonly used disinfectant in India is chlorine, because chlorine addition is cheaper and it makes 100% deactivation of the pathogens. And chlorination is a pH dependent, the efficiency of chlorination is depending upon the pH of the water. Chlorination will be effective at acidic pH, because when chlorine combines with water we get HOCl, and HOCl is stable under acidic conditions. In alkaline condition OCl will be formed, which is 1/100th times efficient compared to HOCl. Then ozone is another important and good disinfectant, but the disadvantage of ozone and UV is it cannot maintain any residual effect. And we have seen that if you want to find out the dose of chlorine required, we have to find out the breakpoint chlorination and add chlorine slightly above the breakpoint dose, so that we will be having enough residual concentration. So, depending upon the condition, whether viruses are present, nematodes are present, we can change the residual concentration. So, the recommended residual chlorine dose in the distribution system is 0.2 to 0.5 milligram per liter. And chlorine can be added in different ways, either as gas or bleaching powder or chlorine dioxide.